Hello everyone. This video we'll be looking at chapter 2 lesson 1, that's about using inductive reasoning to make conjectures. Yes, the words might look new to you because we have not used these words of inductive and conjectures in math during the math classes. So definitely this is something new. Rather than being always solving and showing the steps, this a kind of a different lesson, because here we are going to definitely first think about how we are going to think, and we are going to learn more about patterns and how they are related to math, right? So to start with, this is about using inductive reasoning to make conjectures. So when several examples form a pattern and you assume that the pattern will continue, you are applying inductive reasoning. So inductive reasoning is basically it's based on a pattern of events which are happening, or a pattern of rule which follows something. So inductive reasoning basically is related to patterns. Inductive reasoning is the process of reasoning that a rule or statement is true because specific cases are true. So it's a process of reasoning. Now definitely in geometry you will need reasoning and you will learn that later, but for now inductive reasoning is the process of reasoning that a rule or statement is true because specific cases are true. You may use inductive reasoning to draw a conclusion from a pattern. So we use patterns to draw conclusions for inductive reasoning. A statement you believe to be true based on inductive reasoning is called a conjecture. So what is a conjecture? Conjecture is a statement we believe is true based on inductive reasoning. And what is inductive reasoning? Inductive reasoning is the process of reasoning that a rule or statement is true because of a particular, some cases are true or based on patterns. So certain things are true. So if whatever we are saying is true, that's inductive reasoning, and the statement we believe is true because which is based on inductive reasoning is called as a conjecture. Do not worry, later when we go on you will understand the difference between inductive reasoning and what is the result of inductive reasoning. So to start with, first let's observe what are patterns. All of us know what are patterns. We have patterns everywhere. We follow patterns every day. So to start with, these are two easy examples where we need to find the next item in each pattern. See now, the pattern starts with Monday and then it jumps to Wednesday. So there is something missing here. So what's missing in between Monday and Wednesday? Tuesday is missing. So which is like they're skipping a day of the week and then giving you the next day, right? So here we have Wednesday. So what day will they skip? They will skip Thursday and then they will give you Friday. So what is going to be the next pattern? We need to skip one day. So skipping after Friday we skip Saturday. So the next pattern is going to be, the term in the pattern is going to be Sunday. So this is how we find pattern. This following a pattern, alternating the days, is the pattern of this question. Now let's try that with a number. We have 3, then we have 6. So simply you could see the difference. They have skipped 3. Okay, so or we could say they have added 3, 3 plus 3. Then again from 6 they skip to 9. So which means again from 6 to 9 it is plus 3. And then next is 9. So the term next to 9 is 12, which means again they have skipped 3, added 3, and like they have added 3. So 12 to 15 again there is a pattern of adding 3. So you could see that there's a pattern of 3, or even you might observe it's the multiplication table of 3. 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, 3 fives are 15. So you could easily get the next term. So the next term is going to be an 18, or you could even add 15 plus 3, that will also give you an 18. So whether you use the multiplication table or you use this adding 3, in basically adding 3 means we are using the multiplication table. So the next term is going to be 18, and like that you could find the remaining terms as well. So this is how you find patterns in a series of given questions. So now let me show you how to complete a conjecture. Now here in this slide you saw what is a conjecture. It's a statement we believe to be true based on inductive reasoning. So here they have asked us to complete the conjecture. What does the conjecture say? The product of two odd numbers is what? So product means you know that we have to multiply. So when you're multiplying, and what do you need to multiply? You cannot multiply any number. The rule says odd numbers. So odd numbers, let's just pick two first. So 3 is an odd number and 5 is an odd number. So if I would multiply 3 with 5, that would give me a 15, which is an odd number. Now, do not conclude this with this. Give two more examples and check whether this is correct or not. So let's take two more odd numbers. Say, for example, 7 and 3. So 7 threes will give you 21. So that means this is also odd. Wait, don't write the answer. Check one more time. So this time take 1 and 5 or 7. It's totally up to you. We have many odd numbers. I'm just picking this because they're easy. So 1 5s are 5. So which means this is also odd. So which means the product of two odd numbers is odd. This is how we complete the conjecture. And why did we say that they are odd? Because it's following a pattern. If two odd numbers are multiplied, the answer is always going to be an odd number. So this is how you complete the conjecture. Okay, so the next one here is the number of segments formed by n collinear points. Now you might say, what is this n collinear points? If you are confused on what to do in these cases, you just need to replace. You're just going to replace the number n with a number. So we could replace n by 2, for example, say 2. Okay, so they want you to find the number of segments formed by n collinear points. So, for example, if I have 2 collinear points, how many segments can be formed here? It can be 1. What if I have 3 collinear points? How many segments can be formed? 1 segment, 2 segment, and 3 segments. The complete is also a segment, right? So if there are 3 points, there can be 3 segments. Okay, then the next one, let's try that with 4 segments. So here we have, 4 points. So how many segments can be formed here? This is 1, this is a 2, these are 3. So first let me write down 3. Then go on and find out more segments. We have more segments here. Here this is a segment. From here to here is a segment. And also from here to here is a segment. So that means another 2. Right? Again, from here to here is one more segment. So it's like 3 plus 2 plus 1, which is going to give you a 6. So I think you can understand what the pattern is saying now, right? Now let's try that with 5 collinear points. So 1, 2, 3, 4, 5 collinear points. So how many segments? 1, 2, 3, 4. So my next pattern starts with 4. Then again, it's going to be plus. How many more? I could say from here to here, it's 1. Here to here, it's another segment. And here to here, it's another segment. So 3 more segments. Okay, then again, don't forget you need to count all the segments. So from here to here, it's going to be 1 segment. And here to here, it's going to be another segment. So 4 plus 3 plus 2. And finally, the complete segment, which is 1. So that means here we are going to get the answer as 10. Okay, so you could see that this is a pattern now. So rather than writing here one, only 3, I will write there 1 plus 2 plus 1. So you can understand the pattern. Okay, so you can see now it's 1, then 2 plus 1, then 3 plus 2 plus 1, then 4 plus 3 plus 2 plus 1. So how many segments how many points did we have here? Here we had 2 points. And here how many collinear points? Here we have 3. Here we have 4, and here we have 5. Now for the 6th one, without even drawing a picture, you could say that it's going to be 5 plus 4 plus 3 plus 2 plus 1. So that's going to give you how much? That's going to give you a 15. So this is the pattern which has been, which this particular question, that's the number of segments formed by n collinear points, is what? So we need to complete this conjecture. So how can we determine a conjecture here? Can you see that when we are adding these whole numbers, the whole numbers are always greater than these n collinear points. So it depends on how many collinear points, always you could see the number of segments formed are greater. So what are you going to write here? It has the number of segments formed by n collinear points is the sum of, because we are adding them, the sum of the whole number whole numbers less than n. Alright, so this is when you do not understand something, put it into a drawing, because as I have already told you, our brain tends to understand pictures more than words and numbers. So whenever you have problem, replace this with number. So as I said, like n collinear points, we do not know. So I started with a 2 by drawing 2 collinear points and finding out how many segments that would make, so that you could continue the pattern and find out what is the conjecture for this question going to be. So for this question, it's going to be the sum of the whole numbers less than n. Right. So let's move on to this question. Now this is your practice workbook questions. So we will do them and check whether the answers we have got is correct or not. So find the next item in each pattern. Definitely we need to find out what's going on here. So here it's 100 minus 81. So what's the difference between 100 minus 81? There will be a difference of a subtraction of 19. There's a difference of 19. Is that 19? Do you think that's 19? So from 100 to 89, there's a difference of subtraction of 19. Now how about 81 to 64? How much is the difference between 81 to 64? Again, definitely it has been subtracted, because we can see the pattern. In the pattern, the numbers are getting lesser. So this was for 19. Now if you would subtract 81 and 64, you would see that there's a difference of 17. Okay, in the next pattern, that's the difference between 64 and 49, you would find the pattern is the difference is going to be negative 15. So you can observe that there is something happening. First it started with negative 19, then it is negative 17, then it became minus 15. So what do you think is going to be the next term? How much is going to be subtracted? Yes, negative, subtracted 13 is going to be subtracted from 49. So 49, if you would subtract 13, that's going to give you a 36. So the next item in this pattern is going to be 36. It was an easy one, but then you have to have very careful observation. You have to have very good visual on what is happening in the pattern. Okay, so let's move to this one. Now, this is spiral. So let's see what the pattern is. It starts from the midpoint here and it goes one circle around. The next one, it started from the midpoint and it went one circle around. That's where the previous one stops. But then it completed one more down. Okay, so in the next pattern, we have one from the midpoint. So it goes on. This is where the first one stopped, and this is where the next one stopped, but this continues. So that's the end point. So which means in the one which we are going to draw, it needs to have how many points? Here we have 2 points. Here we have 1, 2, 3 points. Here we have 1, 2, 3, 4 points. So in the next one, it's going to be 5 points. So we need to draw 5 points. So that means I start from the center, and then that's 1. Okay. Now do not give that much of gap. Let's see if I could draw that perfectly. Starting from here. So this is 1. This is 2, 3, and 4. So this is going to be the next figure. How do we confirm that it's correct? Count the points. 1 here, 2, 3, and 4 and 5. So it's 5. So this is going to be your next pattern. That was an easy one. Right. So question number 3 and 4, we have Alabama, Alaska, and Arizona. Now you might be wondering, what are all these? These are the states in, these are the 3 of the states in America. Okay, so well, I know that you're not aware of this because until you read books or you read newspapers, you will not understand what this pattern is about. Okay, so these states, you can see that they are in alphabetical order. So these are the states names which starts with A. So the first one, Alabama, then we have Alaska and Arizona. So if you would check in the internet, you will definitely get the fourth state as, any idea what the fourth state is going to be about? So the fourth state is going to be Arkansas. Though it is written as Arkansas, but we pronounce it as Arkansas, right? So that's the fourth state which comes in the alphabetical order in the United States, right? So the next one we have west, south, east. Now definitely you could say that they're talking about the four directions. We have the four main directions. So the missing direction comes next. So here are the four directions for you. Okay, always we start with north, south, east, and west. So here we have west, south, east. So what's missing? North is missing. So they are going in the counterclockwise direction. Always we say north, east, south, west, but here they're going the other way around. It's a pattern, so they can follow any order they want. Okay, so let's try to do this. Complete each conjecture. So we are going to complete this. Now remember, when I'm explaining, I did tell you when you're completing a conjecture, at least give try with three different numbers. Only then you will write finally what is the conjecture. So the square of any negative number is what? Now square means they're asking about the exponent of 2. The square of any negative number. So let's try to do some. Okay, so if I would say negative 2 square. Now you know this means it's going to be negative 2 multiplied by negative 2. Also you are well aware that if you multiply two negative numbers, your answer is going to be a positive one. So negative 2 square is positive 4. How about negative 6 square? Which means it's going to be negative 6 multiplied by negative 6. Again, when you multiply two negative numbers, your answer is always going to be positive. So we don't need to do anything further because now we already got to know the square of any negative number is positive. And this is how you complete conjectures. Okay, now comes again the number of segments determined by endpoints is. Okay, now this is similar to the explanation question which I did. So again, we do not know what n is. So let's try to find out what they are asking us. The number of segments determined by endpoints. So again, I don't know what's n. So let me replace n with 2. So points. So if I have 2 points, okay, so how many segments is that going to give me? That's going to give me one segment. If there are 2 points, that's going to give me one segment. Okay, so what if I have 3 segments, 3 points now? How many segments is that going to give me? One segment, 2 segments, and 3 segments. So 3. So 1, 2, and the complete one, 3. What if I have 4 points? So how many segments is that going to give me? So 1. Oh, my points are not clear. Let me draw them again. So 1, 2, 3, 4. So I have how many segments? I have 4 points. 1, 2, 3 segments. Then this is the fourth one, this is the fifth one, and this is the sixth segment. So for 4 points, I have 6 segments. And for 3, how many did I have? 1, 2, and 3. Okay, so now let's establish a relationship between these two. Now, the number of segments determined by endpoints is what? We need to find out what do you say, a formula or something which we could say, what's the relationship between these two? So here there's a difference of 2, here there's a difference of 3, right? Then let's find out for 5. Now from the previous, I'm using the same previous example which I used. So it's for 5 it's 10, and for 6 it's 15. So let's find out what's the relationship between these two. Can you see that there is a difference of 1 1 each? That's why in the previous one they said less than n. So here we have 2, 3, 4, 5. So if you want to find out a rule, what you're going to do is you could say this is divided by 2. Okay, or let me start with n. Let me take one of this number 2. Okay, so the number of points is 2. Then how am I going to make this equal to 2 again? I mean 1, because if there are two points, it's one segment, right? So which means I can say that there's a difference of 1 here, right? So that is something like -1. But what is -1? This number -1. So this number, the number of points -1. So this, how much is this going to give you? 2 minus 1 is going to give you 1, but still you will be multiplying that by 2. So 2 multiplied by 1 is 2, but we need the answer as 1. So we can divide it further by 2. That means 2 divided by 2 will give us 1. This, yes, it is a bit confusing, but this is how you need to generate a formula by yourself. You need to think deep. Definitely now this needs thinking. So let's try whether this formula is working with all the patterns. So instead of 2, let's keep this as n now. Okay, so let me take 4. Instead of 2, let me take 4. So what's the formula we derived right now? n minus 1 divided by 2. Okay, so instead of n here, I'll put the number of points as 4. So 4, that's going to be 4 minus 1 divided by 2. So 4 minus 1 is going to give you 3 divided by 2. So 4 3s are 12 divided by 2 is going to give you 6. So is the number of segments formed 6 here? Yes, it is. So when 4 points, the segments are 6. So which means the number of segments determined by endpoints is n minus 1 divided by 2. You can use this anywhere to find out how many ever points are there, how many segments will be formed. Even you want to find out for 10. Now instead of drawing 10 points, you could simply replace n with 10 and find out when there are 10 points, how many segments will be there. So this is going to be 1 minus 1 is 9, 90 divided by 2, 45. So there will be 45 segments if there are 10 points. Hopefully this is clear. You try to do it again by yourself. You will understand what you have to do. Right, let's move on to the next question. Now here you need to show that each conjecture is false by finding a counterexample. Now counterexample is an example which we give to show that the conjecture is false. So the question says for any integer n cube is greater than 0. So we have to prove that this is false. So let's try, instead of n, we will replace n with any number. Say now, for example, n is equal to 2. So if n was equal to 2, it's going to be 2 cube is greater than 0. So the value of 2 cube is going to be 8 is greater than 0. But here the conjecture is right because they said n cube is greater than 0, which means 8 is greater than 0. But we need to prove it false. So the only way we could prove it false is if you would make n equal 0, then this will become false. How is that possible? If n equals 0, that means 0 cube is greater than 0. 0 cube is equal to 0. Is 0 greater than 0? No, it's wrong. So this is the counter example. We are given counter example means you have to find a number which will make this conjecture false. So we could say n equals 0 is a counter example. Or even you could use any negative number. Say in case if I would have taken n is equal to -2. Okay, so I would say -2 cube is greater than 0. Is that going to be true? -2 cube means -2 multiplied by -2 multiplied by -2. So that's going to give me -2 multiplied by -4. 4 multiplied by -2 is going to give me a -8. So is -8 greater than 0? It's wrong. So here again you could say n equals 0, or even you can say any negative number would make this conjecture false. Oh, so we have many examples. The first one we had was n equals 0, or n can be any negative number. So this is a counter example. Right, let's move on with question number 8. Each angle is a right angle each angle in a right angle has a different measure. So the question says a right angle. So let me draw a right angle first. This is a right angle. Okay, each angle in a right angle has a different measure. Is it true? Do you think always if there's a right angle like this, the angles are going to be 20, 70, or for example, we could say 35, 65. Do you think always these angles are going to be in different numbers like this? Or can we find a counterexample? Yes, we can, because now let me show it in a drawing for you rather than putting that in words. They said it's a right angle, so right triangle. So let's draw a right triangle. This is how a right triangle looks. Now each angle in a right triangle has different measure? No, they won't. Because if this is 90, this could be 45, and this also can be 45 degrees. Because together the angles in a triangle will make up 180. So if one of the angles in the right triangle is 90, the remaining two can be 45, 45. So it's not necessary that it needs to have a different measure. So this is the counter example we have. So not necessarily you need to always explain the counter example by using words. You could even use pictures, symbols, numbers, anything to show the counter example. Okay, let's move on to question number 9. Now, for many years in the United States, each bank printed its own currency. The variety of different bills led to widespread counterfeiting. By the time of the Civil War, a significant fraction of the currency in circulation was counterfeit. If one Civil War soldier had 48 bills, so this is where your question starts. If one of the soldier had 48 bills, that means 48 dollars, like the money, but in papers. Okay, so and 16 of which are counterfeit. Counterfeit means fake, or which is not original. And another soldier had 39 bills out of 13 which were counterfeit. Make a conjecture about what fraction of bills were counterfeit at the time of the Civil War. So they want to find out what fraction of each of them was counterfeit, means which was fake or duplicated money. Okay, so let's start with the first soldier. So let me write here the first soldier. Okay, how many bills did he have? He had 48 bills, dollar. That's what they mean. And out of which 16 were counterfeit. But the second soldier, he had how many? He had 39 bills, out of which 13 were counterfeit. Now they want you to find a relationship between the two. So first, to find out, we definitely need to simplify this. So if you would simplify, you're going to simplify this with, okay, let me start with an easy number, a 4. So if you would simplify this with 4, that means divide it with 4, that would give me a 4 4s are 16 and 4 12s are 48. Now you can say that it's still not simplified perfectly. So you can simplify this again by dividing it by 4. So again you divide this by 4, that will give you 4 divided by 4 is 1 and 12 divided by 4 is 3. So 1/3 of the money which the first soldier had was counterfeited, means they were fake money. Let's try this with this. Let's try here. So to simplify 13 and 3, the only factor we have is 13. So we will simplify this with a 13, which means we will divide this with 13, similarly what we did here. So 13 divided by 13 is 1, and 13 divided by 3 is going to give us a 3. So again, which means 1/3 of the money which the second soldier had is also fake. So what is the connection between this? They said make a conjecture. So we are going to make a relationship. So we can see both of them had the amount of money which 1/3 is counterfeited. So simply you need to write 1/3 of the bills were counterfeited. So this is the conjecture we can make out from this question. So because they asked us make a conjecture about the fraction, so definitely we need to write it in a fractional form and find out what's the relationship. It was an easy one, but if you do not understand, read the question 2-3 times slowly and understandingly, you will understand what you need to do. Right, let's move on to question number 10. Again, make a conjecture about each pattern, write the next two items. So they want you to find the next two items in this pattern. So first let's make a conjecture about this pattern. Now 1 is 2. So there is a difference of either plus 1 or multiply by 2. So there are two possibilities. We can either 1 plus 1 gives us 2 or 1 multiplied by 2 gives you a 2. Okay, what about the next one? It's 2, 2. So there's no difference between 2 and 2. Either it has to be multiplied by 1 or it has to be added by 0. So I don't think adding is going to be a pattern here because it's different for this. This is again add 2. So plus 1 plus 0 plus 2 doesn't make any sense. So it's not an addition pattern. Rather, let's follow the multiplication pattern. So this was multiplied by 2, right? And then this was multiplied by 1. Now 2, 4, that means we are multiplying that by 2. Then 4 has been again multiplied by 2. 8 has been multiplied by 4 to get 32. Now if you would observe the pattern, you could see that each number has been multiplied by the previous term. So 32 has been multiplied by 4. 8 has been multiplied by 2. 4 has been multiplied by 2. 2 has been multiplied by 1. So that's the pattern which they are following, right? So what do you think is going to be the next pattern? So 32 has to be multiplied by what now? 32 was multiplied by 8 was multiplied by 4 to get 32. Now 32 for the next pattern, 32 has to be multiplied by 8. So 32 multiplied by 8 is going to give us 256. Okay, so this is the next pattern. So it's like from the previous number, each number has been multiplied by the previous number. Okay, so to get the next number now, with what am I going to multiply? I am going to multiply 256 with 32. So I hope you could understand what we are trying to do here. It's nothing but we are just multiplying this 2 to get this number. We multiplied this 2 to get this number. That's what, so the pattern goes like that. Multiply this 2 to get the other one. So now we are going to multiply this 2 to get the other number. So what's the next term going to be? The next term is going to be 8192. So if you would multiply 32 with 256, that would give you 8192. So what's the conjecture we could make here? Each term has been multiplied by the previous one. Each term has been multiplied by the previous term. This is the conjecture terms. Okay. So here, this is an easy one. Once you look at it, you know what's the next thing going to be. So it starts with a point here. Then we have, it's like every vertex. So here we have this vertex. Then in the next figure, they left out this vertex. They came to the other one. So which means definitely they're going to leave out one vertex and your point is going to be on the next one. So what's the next pattern going to be? In the next one, they will leave out this vertex and then they will put the circle on this one. So you need to draw a pentagon. They want you to do two terms, two of them. So first, let me draw a pentagon. So this is one pentagon. This is the second one. Okay, now they both may not be the same size, but that's fine, perfectly fine. So according to the pattern, they're leaving out one vertex and then the next one. So leave out this vertex, so your point is going to be on this. Then for the next term, they will leave out one vertex, so the point is going to be here. So this is the pattern. So how are you going to write the conjecture? You could say that the point skips over one vertex. Or you could write it in perfectly in your own words, but then the idea needs to be the same. And that too, you can see that it is going in a clockwise direction, not in the counterclockwise. So you need to specify when you are writing a conjecture, be as give the detailed explanation as possible. So the point skips over one vertex in the clockwise direction, so that the other person who is following the pattern could easily follow it in the clockwise direction. So make sure that you're giving clear instructions in the conjecture. So this is all what you needed to do in this lesson. It was an easy one. Hopefully you have understood. So comment and let me know how many of you have got the answer right. So till we meet again in the next video, keep practicing.